Begin with the basics. What exactly is matter? Matter is anything that occupies space and has mass. It's all around us, from the pencil you write with to the distant stars twinkling in the night sky. But not everything we encounter is matter. Abstract concepts like love, hate, or thoughts don't have mass or take up space, so they aren't considered matter. On the other hand, something as subtle as the smell of perfume is matter, because it's made up of tiny particles floating through the air. This distinction helps us understand what makes up our physical world and what remains in the realm of ideas. Now, let's see how our understanding of matter has evolved over time. Throughout history, humans have tried to define what matter is. Ancient philosophers spoke of the Panchattva, air, earth, fire, sky, and water as the fundamental elements. These ideas shaped early thinking, but as science advanced, our classification of matter became more precise. Modern science now sorts matter based on its physical properties and chemical nature. This shift from philosophical elements to scientific classification marks a major leap in our understanding. But what is matter really made of? To answer that, we need to look closer down to the tiniest particles. Matter isn't continuous, it's made up of countless tiny particles. Imagine a single crystal, it contains millions of these particles. Even after diluting a colored solution several times, the color remains, proving that matter can be divided endlessly into smaller and smaller pieces. This particle nature is the foundation of modern science. But how do these particles behave? There are three key rules. First, particles have space between them. For example, when salt dissolves in water, the water level doesn't rise because the salt particles fit into the spaces between water particles. Second, particles are always moving. Light an incense stick and you'll notice the scent spreads throughout the room, evidence of moving particles. Third, particles attract each other, but the strength of the attraction varies. For instance, it's much easier for a diver to move through water than to break a block of wood. These invisible rules shape everything we see and touch. Matter exists in three main states: solid, liquid, and gas. Each state has unique properties. Solids have a definite shape and volume, are incompressible, and are rigid. Liquids have no definite shape but a fixed volume, are slightly compressible, and can flow. Gases have neither definite shape nor volume, are highly compressible, and flow freely. These differences arise from how closely packed the particles are and how strongly they attract each other. For example, gases can be compressed easily because their particles are far apart, which is why we can store large amounts of gas in small cylinders. Solids, on the other hand, are usually rigid, but some, like sponges, can be compressed because of air trapped in their pores. Understanding these properties helps us see why matter behaves so differently in each state. Matter can change from one state to another, solid to liquid, liquid to gas, and even directly from solid to gas, a process called sublimation. Examples include camphor, naphthalene balls, and dry ice. But there's a mystery. When you heat ice, its temperature stays the same as it melts. Why? The answer lies in latent heat, energy that's hidden and used to break the forces holding particles together, not to raise temperature. This is why steam burns are more severe than boiling water burns. Steam contains extra latent heat. Evaporation, another transformation, cools its surroundings because particles absorb energy from their environment to escape into the air. Factors like surface area, temperature, humidity, and wind speed all affect how quickly evaporation happens. These hidden processes reveal just how dynamic the world of matter really is. To study matter, scientists use precise tools and units. Temperature is measured in Kelvin and pressure in pascals. For example, to turn a gas into a liquid, you decrease its temperature and increase its pressure, a process called liquefaction. By understanding these measurements and the invisible world of particles, we can unlock the secrets of the visible universe. The journey from ancient philosophy to modern science shows how our grasp of matter has deepened, revealing a world of constant motion, transformation, and hidden energy. As we continue to explore, the particle perspective will keep guiding us to new discoveries.